1. All right, so we're looking at Math 2, Module 1, Topic 1 notes, and we're going to do the first page today. We're not doing all of it. So for today, we're going to do the circle stuff, circles and angles. So if you look at box number 1, the first box, we have segments in a circle. So this circle is called circle O because of the center being labeled as the point O. So you can see O is literally in the center, so it's called circle O. And the center is O. And a radius, in case you guys don't remember, is halfway the distance of the diameter, which means you start at, here, let me use a pen, not a highlighter. Okay, so it says GO and it has a line on top, so that means we start at G, which I'm putting a blob on right there, and you go towards O. So this blue line right over here, this is your radius. And a radius goes from the outside to the center, okay? It's that distance. And then a chord is AS. Let me do that in a different color. Let's do purple. AS, so it starts on A on the outside of the circle, and then it goes across the circle onto the other side of the circle, somewhere else on the outside. So chords are outside to outside. Radius is outside to center. And then finally, we have diameter, which I guess I'll do in green for diameter. We have FD, so look at where F is on the outside. And then if you trace the line going all the way to D, you pass through the center. It's very important that it passes through the center, and then it ends on D on the other side of your circle. Okay, so just to recap, radius, it's outside to center, and it's done in blue. A chord is outside to outside, and diameter is outside to center to outside. Any questions? Okay, if you have any questions, feel free to interrupt me, okay? Let's look at box number 2. Box number 2 is lines and circles. So this is circle O. Once again, it's circle O because your center is labeled O, so it's circle O. And it has a tangent FD. I'll just do that in a green line, why not? FD. And somebody unmute yourself. Tell me, how many times did line FD touch the circle? Is it once or twice?
Once.
Once. Good. I'm just going to put a 1 there. So it touches once. Okay. Good. Now what about secant AS? Oops, secant AS. Here's A, here's S, and it touches the circle how many times?
Twice.
Twice. Great, thank you. So that's the difference between a tangent and a secant. One thing I didn't say is the point of tangency on tangent FD is literally the point where it touches it. Okay, so that's point F. That is that point. Point F is where it touched the circle that one time. Any questions about box number 2?
How do you know how many times it's touching the circle?
Oh, so like if you look at the picture, I'm just gonna zoom in really close.
Right.
Let me erase like my lines so you can see more clearly. Can you see that this straight line on FD, the one that I just got rid of all the green marks on, it literally only touches like right there at that one spot. This spot. Yeah, so then you know it touches only one time.
Oh, okay.
And so this is a tangent.
Okay, thank you.
Let's go on to number 3, arcs and circles. Okay, so circle O, once again, because the center is the letter O, and there's different types of arcs. So an arc is just like a curvy part on the outside of the circle, okay? It's a part of the circle. That's what it says right here. Let's start with our minor arc. I guess I'll trace over that in green, I don't know. Minor arc AD. I'll just put a green dot there so you know I'm gonna trace this one in green. A curves all the way to D. And this is a minor arc because minor is kind of like small. It has a similar meaning to small. And it's between 0 and 180 degrees of the circle. So just to remind you guys, a whole circle is 360 degrees, right? I don't know if you guys remember this. That's why we should go over it, because it's been like 7 months since you guys have last done math. Also, that's a really ugly circle that I drew right there. Okay, so this is 360 degrees is the whole entire circle all the way around. So 180 would be halfway of that, because half of 360 is 180. So a half circle takes up 180 degrees. Okay, so a minor arc is smaller than 180 degrees. So if we cover less than this bolded part of this line, as you can see over here, this green part is smaller than that. It's less than half of your circle. That's a minor arc. Now, on the other hand, you can have a major arc. Major arc is AFR, so let me trace all that. Wrong way. A, all the way to F, all the way to R. I don't know why my lines are so squiggly right now. But as you can see, we are tracing all the way around. This is more than half the circle, right? So this is a major arc. So major meaning like bigger, so meaning more than half your circle. And then right in the middle, you got your semicircle, which is exactly 180 degrees. That's why it says half a circle, exactly 180 degrees. So let's trace out that. R, all the way to A, all the way to D. Okay, so this RAD is exactly half a circle. And since it is exactly half a circle, it is called a semicircle. Do you guys have any questions on this part?
Nope.
Okay, check the time. Wait, I think I hear some talking, but can you get closer to the mic? Or is that a no? No? Okay. Interrupt me if you have any questions, okay? Do not be shy. I will not be mad for you interrupting me because I'm telling you to do it. Okay, number 4, angles and circles. Circle O, central angle, SOF. Let me just put that one in blue, SOF. The vertex is at the center. So notice where the vertex is at. The corner, which is the vertex, is at the center of the circle. Okay, and then that's as opposed to the inscribed angle, ARD. ARD, let me do this in green, ARD. The vertex is not at the center. The vertex is on the outside of the circle. It's called on the circle. Okay, so that's 2 different types of angles. Oh, by the way, I know I said it on the syllabus day, but maybe some of you are new into the class and weren't there on Friday. You can use notes on tests. I'm going to allow it. So yeah, take notes so that you can use it on the tests whenever we have tests. Number 5, measures of arcs. So this is still circle O. Let's do a central angle first. Central angle, the angle size. Okay, so this is the central angle. This
Excuse me,
angle size.
can you go back to the last box?
Oh yeah, sorry. Let me just go back.
Okay, thank you.
So it's the same picture for this one, except they already had colors there, so I'm just going to stick with the color that they have. So for a central angle, if this angle measures, like let's say, this looks about 50 degrees. Let's just pretend it's 50 degrees. I'm making up a number. Then the arc is also measured at 50 degrees, okay? So they're equal. That's why it says angle equals arc equals angle. They are measured, they have the same measurements, okay? So it's 50, then it's also 50. This is as opposed to, I'll do this one in purple, I guess. I don't really have a red, so I'm just gonna do it in purple. Okay, this is your inscribed angle. And for your inscribed angle, the angle is half of the arc, or the arc is double the angle. Those are the two formulas you can use. And so, for example, if this angle was measured at, looks a bit like a 30 degrees, then that's half of the arc. So this would be 60 degrees. So I just put numbers there to give you an example, okay? Do you guys have any questions about this one? Okay, I'm gonna just read number 6 to you guys. Conjecture is to use experience and reasoning to presume that something is true. A postulate is a statement accepted to be true, and a theorem is a statement proven to be true. Okay? So this is like, oops, whoa, I didn't mean to do that. This is like a fact proven. And then a postulate is just like, it's like we accept it to be true. We assume it's true, but we don't know like for sure. And then conjecture is just like, well, every day okay, that's like when you just use experience and reasoning, but we don't know if we can accept it yet. So this is the least solid version of it. Conjecture is the least solid, and theorem is like for sure. And postulate is like in the middle, okay? Vertical angles. Two non-adjacent angles formed by intersecting lines. So they're the ones on opposite sides of each other. Okay, like 1 and 2, those are vertical angles. They're on the opposite. You zoom out. For vertical angles, they're always going to have the same measure. So as you can see, number 8 is a different picture of angles, but they're still vertical angles, 1 and 2, because they're on the opposite sides of each other, like butterfly wings. And they are congruent, so that means they have the same measurement. So if this was 30 degrees, then this is also 30 degrees. They're just congruent. Okay, any questions about those? I went through a few without asking if you had any questions, so feel free to ask. Okay, let's see what's next. Linear pair. Linear pair is two adjacent angles that form a line. So that's this one and this one. So they're right next to each other. They're not opposite of each other. They're like shoulder to shoulder. They're right next to each other. And when you have two angles that are shoulder to shoulder with each other, they're going to be supplementary, which means they add up to 180 degrees. So let me write that out in an example. Two numbers that add up to 180 that I'm just coming up with right now, like let's say 50 plus 130, right? Those two add up to 180. So this one could be 50, then this one has to be 130. They will both add up to 180. Because they form a straight line, and remember a straight line is 180 degrees, just like halfway across a circle. Questions about those two? Okay, make sure you guys do ask questions if you have any though, because I think some of this stuff we were supposed to go over in Math 1, but as you know, Math 1 kind of, didn't finish last year. Okay, so let's do number 11, tangent and radius diameter. So tangents are perpendicular to the radius or diameter at the point of tangency. So remember, a tangent line touches the circle only once. So when you're looking at that, our tangent line is over here, D, B, E, and it touched the circle at this point of tangency of B. Wow, that was not a good arrow. Okay, point of tangency. Okay, so B is our point of tangency, and so that means this tangent is perpendicular to the circle. That's why they have the red square there. It's perpendicular at the point of tangency. At corner B is going to be tangent to the radius or diameter.
You're paused. I don't know if you can hear us.
Oh, my internet must be really bad.
I think you paused. Yeah.
Okay, like my screen is paused, or can you hear my voice?
Right now, you're fine. Well,
Okay.
I
We're kind of
can hear.
paused.
Right now,
your
you're
screen's moving
fine.
now.
Okay, where did I cut off?
Well, you cut off when you were talking about the red box.
You were
for
saying.
number 11.
Oh, okay. So it's still on number 11 box.
Yeah.
Okay, that's good. Thanks for letting me know.
Okay.
The internet. Okay, so what I was trying to say before the internet rudely cut me off was that this is your, the blue line is your tangent line, and your tangent line touches the circle only once, and where it touches the circle, which is at point B, that is called your point of tangency. So I put the blue dot there. And that's when I wanted to point out that tangents are perpendicular to the radius or diameter at the point of tangency. So at point B, you get that red box because it means it's tangent to our, here's our radius. So our radius and our blue line, the tangent line, are perpendicular to each other, and they meet at point B, the point of tangency. That's what I was trying to say. Okay. So in case you guys don't remember, a right angle is an angle that measures at 90 degrees. So that means over here is 90 degrees. That also means over here is 90 degrees. You can draw a box on the other side if you like to. Do you guys have any questions on that box? Or number 11?
Are we supposed to be writing this down?
You don't have to. I just want to like talk it through with you guys, so that so that you don't have to just read it all on your own. Like when I say you can use your notes on the test, you can pull up the file and use it if you like. But if it helps you to write it down, then you should. But the video will always be there. So if you don't have time to write it down right now, like if I write too fast, your internet dies, whatever, I'll post the video because I'm recording. Okay.
Okay.
Okay, cool. So number 12, circumscribed angle, an angle with its sides tangent to the circle with a vertex that is outside of the circle. Okay, so this is a circumscribed angle, which means it's got two tangent points, okay? So remember, tangent point touches the circle once. So it touched it once over here and once over here. So that's why the sides are tangent to the circle and the vertex is outside the circle. So the vertex is over here, point Y. So then you get your overall angle as, I'll just highlight it in green. This whole thing, that is your, oops, just let me write. That is your circumscribed angle. So I drew the angle in green, and then the sides that are tangent to the circle, I just put in blue, and the vertex I put in yellow so you can just see them more clearly. Any questions on this one? Okay. Zoom out. Let's talk about, no, I think that's it because we're just doing circles today. We don't really need to talk about the polygons.
Can you go back to the first box?
Yes.
Okay, thank you. Okay, thank you.
You're welcome. Any other questions for anybody about anything? Anything on the notes, I mean, before I end the recording? Okay. Will we be able to see the notes? Where will we be able to see the notes? Okay, good question. Let me stop the recording first.